Today I went to the Rideau Lakes Amateur Radio Club hamfest, which was held in Smith Falls, Ontario at the Smith Falls Curling Club. It was quite a show. It was very interesting. I'm going to post a separate video on that. I've been looking for a VOM for quite a while now, and I used one at a good price, maybe a Simpson 260 or a Heathkit MM-1. And when I saw this one today at the hamfest on a table, I thought, oh, it can't work, it can't be working. And I thought, oh, it looked kind of dirty, but so I picked it up, and I looked at it, and the needle is straight. It moves freely, doesn't seem to bind or stick. Always comes back to the same spot when you move it. Now that doesn't guarantee that it won't bind at the top end, but at least that looks like the movement is free. Now it could be burned out, I don't know. The guy said it works, so the switch is nice and free, moves freely, controls all move freely. The handle's intact. It's not leather like the Simpson handle, but it's a vinyl of some sort. But it's intact. The case itself, there are no visible cracks. Now these old meters, the cases are Bakelite, which is strong up to a point, but it tends to be brittle. So if they're dropped on the corner, usually they'll crack or there'll be a piece missing. This one seems okay, so didn't come with any leads or anything, but so I'm hoping I can get this working. I'm looking for a VOM to complete my bench. So let's take a look at it. I get some test leads and plug it in to some power. Plus common, 1500 volts. Got some voltage here we can use. Okay, what do we got here? 25 volts. Well, I'm showing a little bit of voltage there. Let's turn it, at least it works. Seems to work. Let's change that to the 500 volt scale. And on the 500 volt scale, I'm reading 25 volts. Okay, let's pull this out. We'll zero the meter. That's pretty good. Okay. So this is the 150 volt scale. So that's 15. We're reading about 24 volts. What do we got here? We got 25 volts. Pretty close. The 50 volt scale. We're reading just under 25 volts. Well, let's bring this down to 5 volts. And we'll go to the 5 volt scale, and it reads 5 volts. The meter works. All right. DC plus. Okay, so let's go to DC minus. And it works. It's working. It's amazing. Let's change to AC. And see if we can get a reading on AC. Okay, I've got it on the 50 volt range. It's about 10 volts AC. It's on the 50 volt range. Switch to the 5 volt range. Not too bad. At least it works. This is unrestored. It's totally the way I found it. Now, I'm sure this is way too much to ask, but let's put that on DC plus, and we'll go to the ohms scale, R times 1, and we'll see if we get any kind of reading. Oh my goodness. There is something there. Wow. R times 100. 0. R times 10K. Oops. That's dead. Nothing. Wow. Resistance works. 2 of the 3 resistance ranges work. Alright. What else does this thing do? Minus 15 amps, plus 15 amps. 5 kilovolts DC, 5 kilovolts AC. Measures up to 1500 volts AC and DC. That's quite amazing. Well, let's take a look and see what's inside. Wow. Well, this is why the ohms work, the low ranges. Higher range, the mega ohms, needs 4 AA's, and they're not there. Okay, well, super heavy duty boss man. Looks pretty neatly built. Very clean. That's the little instrument rectifier that lets you measure AC. That little gray thing. I'm just looking at all the resistors. They're precision resistors. They're strange values to make the thing work. And actually they seem intact. I don't see anything burned. They all seem intact. Switches look like... You know, this thing doesn't look like it's seen a lot of use. Look at the contacts on the main switch. They're very clean. This could be a fairly late model. I don't know if there's no date on it. They don't put dates on them. 20,000 ohms per volt DC, 5,000 ohms per volt AC. The meter movement itself was made by Simpson Electric Company, Chicago. So, although this is a poor man's Simpson 260, it's got a Simpson meter movement. Here's the shunt for the 15 amp ammeter. This has to go. 0.1, 600. I got plenty of them. Wow, this is amazing. Looks like we can get it working. We just have to clean it up. We have to deoxit the switches, change the capacitor, put new batteries in, clean the contacts, clean the controls. Well, there's only one control really. Give it a bath, and looks like we might have a workhorse. That battery contact needs a good scrape, that's all. Wow. Not bad for $8. Yeah, I happen to have a 4-pack of Amazon Basics. I'm quite happy with them. They seem to have really good capacity. I've never done any formal tests, but I'm sure others have. So, plus, minus, oh boy, don't fit too good. It's not too good. Why don't they fit? Okay, well, okay, so this could have something to do with it. Look at that. Alright, well, I can clean that up. Okay, a little sanding and a little cleaning and a little bending, and I've got it so that it'll actually work. Wonder if my Heathkit nut starter will work with that. Look at that. I'm using a nut starter, a Heathkit nut starter. God, those guys are amazing. I love Heathkits. Plus, minus, plus, and minus. Okay. Okay. That's the R times 10K scale. That's what that powers. Okay, test leads. $10K. Nothing. R times 100. Oh. Yeah, okay. Well, maybe it needs a C cell. Let's see what that one says. 1.5 volts, DC plus. Oh, 1.5 volts. Okay. Let's get a fresh one anyway. Or at least a fresher one. Deoxit on the contacts. Minus plus. All right. Now we know this worked last time. Okay. Zero it. Ah, look at that. 10K. Beautiful. We have ohms. So, R times 1, put this on low, $15 ohms. Okay, 22 ohms, 100 ohms. We'll go to this R times 100, 1 ohm. 330. Looks like we need a bit of calibrating. 1000. 3.3. Yeah, we need a bit of calibrating here. 10K. R times 10K. Well, that looks pretty good. Okay, here's a megohm. 10K times 100 would be a megohm. Well, let's zero that out. Okay, there. Now let's try it. That's closer. No, that's a megohm, sorry. It's closer anyway. 470K, that looks good. 220K, 100K, 47K, 22K, R times 100. Well, on this thing you gotta zero it. Yeah, ohms is only on DC plus. Okay. 1K, 100 times 10. 470K, 100. 100, 1 times 100. Cool. Well, ohms works. Okay, let's take a look at this. All right. Looks like new. One thing I like about this is that there's no stop. You can go directly all the way around. Like that. Saves time. Grease the detents. This almost looks like factory built. The soldering is excellent quality. All the leads are bent nicely, right angles. No wonder. So we have to replace this. I've got 0.1, 630 volt. That can go right there. Point 1, 600 volt. Okay. Done. And the control. That's our ohms 0 control. And our function switch. Beautiful. Looks like new. Beautiful. Okay, I need some Q-tips. Okay, I got a Q-tip. We'll put some deoxit on it and clean up our banana jacks. Kind of messy. Well, they're clean now. Okay, just for curiosity's sake, let's test this 0.1, that 600 volt capacitor that came out of the MM-1. Okay. Open. Good. Shorted. Good. Now we'll hook up the capacitor to the leads, and it's a regular cap, 600 volts. Okay, let's check the value. 0.103 something. That's close. That's really close. That's good. And let's check for leakage. .67. It's coming down. 9.1. 9.09 microamps. Okay, that's still fairly high for this capacitor. Let's compare that to a brand new one. Here's a brand new, it says 104K, that's 0.1 microfarad, 630 volts. This one I got from David at Just Radios. It's brand new, never been used, never been installed, never been soldered, and we'll see what this one does. 600 volts, capacitor value 0.1004 or 5 microfarad. That's really close. Let's try the leakage, see what happens. 0 microamps. So a brand new capacitor. Has 0 leakage. Okay, let's try this at 630 volts because that's the rated working voltage for this capacitor. And we'll check the leakage again. 0 microamps. So it's a good thing we changed that capacitor in the volt ohm meter. Good job, David. This is a good place to get capacitors. It's called justradios.com, and they're good capacitors at a reasonable price. Okay, testing the completed instrument. Before the MM-1 is used on equipment having large voltages or currents present, it should be thoroughly checked to make sure all functions are operating correctly. Ohm meter. Set the function switch to DC plus and the range switch to RX1. Short the test leads and rotate the ohms adjust control. The meter should read from slightly below full scale to above full scale. Repeat this procedure on each ohm range. Yep, it goes there. Okay, R times 100 and R times 10K. Ohms, check. Okay, DC voltmeter, set the function switch to DC plus and the range switch to 1500 volts. Connect a 1.5 volt battery across the test leads and decrease the range switch voltage on the MM-1 in steps. From a barely perceptible indication, the meter should read progressively higher amounts until full-scale deflection is reached on the 1.5 volt range. Barely perceptible. Okay, 500 volts. Barely perceptible. 150 volts. Yeah. 50 volts. They've got to be kidding. Okay. 5 volts. Okay, that's the 5 volt range. 5 volts. 1.5 should be up there. Well, this isn't quite 1.5. Yeah, this is just under 1.4. 1.446. So this isn't too bad. Yeah. That's an old D cell. Set it to DC and reverse it. It's working. 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 Barely perceptible. Okay, AC voltmeter. Set the function switch to AC volts, and using a low voltage source of AC, such a filament transformer, repeat the same process used on the DC ranges. Do not try the 1.5 volt range directly on the transformer. Connect a potentiometer of about 50 to 100 ohms across the transformer secondary. Yeah, okay. Well, we can do that. Okay, so now we're ready to test the AC functions. I've got my old HP 200 CD wide range oscillator. This thing puts out up to 28 volts, so we'll have some useful AC voltage to test with. Okay, we'll dial in 60 hertz, 60 cycles, times frequency times 1. Okay, we'll put the voltmeter on AC. We'll switch our Heathkit meter to AC. And we're on the 1500 volt range. We've got about 27.5 volts. I don't know if you can see that through the meter. And it's just barely registering here on the Heathkit. So let's go down to the 500 volt range. It's registering about 25 volts. Let's go down to the 150 volt range. If you look at the 150 volt range, you'll see this is just under 30 volts. It's between 25 and 30. We'll go to the 50 volt range, and we're measuring about 26.7 volts. So it's pretty close. Okay, we'll dial it back to the next range is a 5 volt range, so let's dial it back to about 5 volts. Okay, 4.93 volts. Let's go to the 5 volt range. Look at that. That's pretty good. At what voltage do we get 5 volts? we get 5 volts at 5.58. Okay. So let's go down to the 1.5 volt. 1.558. And if you look at you have to look at the red range here for AC at low voltage AC, because the nonlinearity of the instrument rectifier affects the reading. So I've got about 1.89 volts, and this reads 1.5. So that's as close as you're going to get with this meter, I suppose. We're not here to calibrate it. We just want to make sure that it works on all the ranges, that all the ranges are functional. To measure current, the function selector switch may be set to DC plus or DC minus position depending upon the direction of current flow. So let's set it to DC plus. The test leads are then connected in series with the load circuit, never in parallel, as this would put the meter across the voltage supply. Damage to the meter will invariably result. To measure very small amounts of current, such as 2 grid current, the range switch is set to the 150 microamp position and test leads inserted in the common and plus jacks. So we're on the 150 milliamp range. Let's turn up the juice and see what we can do here. We got 150 milliamps and we've got a little over 15 volts. Yeah, well that seems about right. Okay, so this is good. Everything's working so far. And we'll put that in there. That deoxit worked beautifully. These things don't scrape anymore. Okay, so 150 milliamps, DC plus. This is in, now that says 0.5, not 5. Alright. See if we can get some juice going here. What do we got? We got 25 volts through 1,000 ohms, and I've got 0.5, so we've got about 22.22 amps, almost a quarter of an amp. Yeah, and it is getting warm. A little bit, almost a quarter of an amp. Okay, we're going to amp this up a little bit. I'm going to put in here, we're going to leave it on the half amp range, and I'm going to put in a 5 ohm resistor instead of a 100 ohm resistor. Watch this sucker jump. Look at that. And I can get a half amp at only 2.5 volts. Yep, that makes sense though, doesn't it? Oh yes, and as a finishing touch, I added some self-adhesive vinyl feet to the bottom of the case to keep it from sliding around.